Assalamualaikum warahmatullahi wabarakatuh. Hello guys, so today I will demonstrate the question 3 and 4 for the Dinaffit-Huttenberg calculation method. But firstly, I will show you the thing that I used is the robot of arm robot using for Dove. Now, I will explain a bit about the part of arm robot. The first thing is the base. Now, the base is from here for the foundation of the arm robot, and then in here we can see is the gripper, or we can say is the end effector of the arm robot. And then for the joint, there are 5 joint from the base. Now we call this as the servo, and then from this is the second servo, also this for the third servo, this is the fourth, and then from the gripper is the last servo on the fifth. And then next I will show you the calculation of the Dinaffit-Huttenberg method. This is what I calculate by the Dinaffit-Huttenberg method. Firstly, this is the picture of the angle, the triangle for the y-axis, x-axis, and z-axis. And then I drew 2, and also I draw about the parameter of the Dinaffit-Huttenberg just like this to get the parameter. And then after we collect the parameter, we can make the table of the DH method just like this. And then from there we can start the calculation of the DH method by the unknown value of the first length of the arm robot is 10 centimeters, and then the second length is around 18 centimeters, just like that. After that, we can we get the equation of the question, that this is to determine the final position of the n effector x and the final position of n effector y. Now, for the equation itself, the first equation is for determining the n effector x. The final position of n effector x is the length 1 multiplied by cos q1, and then add by the length 2 multiplied by cos q1 plus q2. Also, for the third question, the angle we use is for the q1 is 20 degree, and then the q2 is 30. So that's it for the equation of the n effector x. And then for the n effector y is same as the n effector x equation, but for the n effector y we don't use cos, but we use sin, just like that. And also we can start the calculation and we get the result just like this. Now, the result itself, we got the n effector x is around 20.9671038 centimeter, or just say 20.9 centimeters. And then for the n effector y, we got the result 70.209000140 centimeter, or just say 17.2 centimeters. And then for the n effector z, just 0 centimeter, because it not the part of the calculation, just like that. And then also I will show you my draw sketch. This is my sketch for the third question. From here we can look at the link for the what we can say, the information of the sketch itself. The first link we drew from here, and then the second link we drew in the center in here, and the last link we drew in here. So basically, this sketch is represented with the arm robot itself. Now, after we draw the link, we can put the angle. The first angle we put in the near the first link is 20 degree, and then the second angle, or the key 2, we put in nearly the center of the link, or just say 30 degree. Now after that, we can determine the n factor x and y based on the manual measurement. X is around 18.848077753 centimeter, or just we can say 18.8 centimeter. And then the n factor y, we get the result 70.32493904 centimeter, or just we can say 70.3 centimeter, and n factor z just 0, as same as before. Now also I will show you again about the sketch as for the fourth question, just like this. Now this sketch is represent the arm robot. The first link is start from here, and then the second link here, and the third link up here. Now from there we can put the degree for 10 degree near the first link, and then the 50 degree near the second link. And then we look at the first link to here, to here. For n factor x, we get the result 21.5 centimeter, and then the y we can get here up here for 15.5 centimeter. Then the 30 degree is just from here to here. Now yeah, approximately like this. Now as you can see, just like this. Okay, so that's it for the answering for the question 3. And now let's begin for the question 4. Actually, the fourth question is same as the question 3, but we use the different angle. So for the question 4, I'm sorry, here we know, just like the answer before, we know the angle, triangle like this, and then we draw the parameter just like this. This is the parameter, and then after we get the parameter, we make the table for the TH method, and after that we can start the calculation just like this. And note that we use the different angle. Yeah, the key one is 10 and the 10 degree, and then the second or the key 2 is 50 degree, just like that. And the result we get is the n factor x, just like that. And then I will show again for the arm robot representation. The degree for the first is 10 degrees, so it must be down, but not until up, down, not fully down. And then the 50 degree, maybe just up until here, approximately, just like this. Okay, so that's it for the 2 measurement method that I used for the question 3 and question 4. So for the conclusion itself, for the result of the calculation by Benefit-Huttenberg method and manual measurement, we get the result as a deviation between x and y. And for the third question, I get the deviation around 5 centimeter for x, and for the y, yes, for the y 5 centimeter too. But and then for the fourth question, I got the deviation around 2 centimeter for x and 2 centimeter for y. So that's it for the conclusion, and it might be caused by the adjustment of the robot or the calculation of the robot. Yeah, maybe just like that. Thank you for kind of your attention. See you. Wassalamualaikum warahmatullahi wabarakatuh.